We have Don Rule from Translational Software, who will be speaking on challenges and opportunities in regulating pharmacogenomics.
Thank you. Hello, thank you. I really appreciate the opportunity to visit with you all. We are in the commercial space. We sort of stand on the shoulders of the work that you do. And it's kind of nice to meet you and find out where you're going. The background, if you're not familiar with translational software, the basic idea came when the human genome was originally sequenced. The thought came to me, well, if you can digitize biology, can a software person make a contribution to human health? And more importantly, can I use what I learned in commoditizing hardware and software to push precision medicine forward faster? So we started out I started in 2009. Huda actually recognized me in Starbucks in 2011. So we had the software and the content. We first shipped in 2013. As of 2015, 60% of the tests that were reimbursed by CMS were processed by labs that were customers of ours. Actually, in the panel this morning, 3 out of 5 people have used our results, and given the nature of my talk, I'll let them self-identify. Christine, this would have been escitalopram, but I couldn't fit it on the bottle. Given where we were in the industry, we got a letter in May of 2016, and I learned last month that there's a technical term for this. It is "it has come to our attention" letter. Essentially what they were saying is they thought we were a medical device. And I went back to them and said, listen, I'm following the advice of Sandy Aronson at Partners Health. They had interpretive software for cancer mutations, and essentially they had the agreement that as long as they were GMP, that good manufacturing processes, they were class 1 device and therefore okay. That didn't fly. So we ended up submitting a de novo submission in December of 2016 that included both our content and the software. Ironically, the day after the 21st Century Cures Act passed, and one portion of the 21st Century Cures Act was a carve-out for clinical decision support systems that essentially said if you supply enough information to a physician that they can make a decision for themselves, then it is not a regulated device. So, and that provision was not supported by the FDA. So in April, when they finally got back to us, they said, well, the content is not a priority at this time, but the haplotyper, the ability to translate from a bunch of SNPs to a diplotype, that is because, and very logically, a physician of ordinary experience cannot take that input and through, no matter how many websites you give them, they're not going to be able to translate that. So it is realistically a medical device. We worked on another submission for that. We missed a deadline and it was withdrawn before we could address the problem. So things were going along. We were actually re-architecting it, trying to make the haplotyper more table-driven than algorithm. Christine told me in 2008 that the FDA is allergic to algorithms. I still remember that from your notes. Things were going along. In January, 23andMe got clearance for a 510K for pharmacogenetics. And they did a press release, the FDA did a press release, but the FDA at that point had a precedent. So they started to get aggressive with labs. And one of them that they were aggressive with, and the theory behind this is that Innova had put a huge banner out in the right field fence of a Washington Nationals game, and that brought them to the FDA's attention. I don't know whether that's true or not, but it's a good story. So the FDA approached Innova. Innova said, well, we're a lab-developed test, so buzz off. That led to a warning letter. Innova decided, well, they want to have other relationships with the FDA, easier to withdraw from the market, which is a shame because they were a very, very good lab. Now, it isn't clear that it was never stated between FDA and us that we were the supplier to Innova, but we assume they know. We got a meeting with the FDA in June. So in June, we went in saying, yeah, the haplotyper, we're working on it. We're going to get that done. We are adhering to the clinical decision support decision that you'd made. And we had questions. There were two questions, essentially, that they had put in a press release that the information that Innova was using for sertraline and escitalopram was they didn't say incorrect. They said they couldn't support it with information that they had. So we brought that up and said, well, this is the information that we have that is published since those drugs were approved. That didn't go anywhere. So what we learned from that pre-sub was we have to submit very soon. B, the content has to be documented, has to be proven, as well as the software. But they offered the 23andMe predicate. And from their perspective, that was a great solution in that the 23andMe had invested the money, they must have traded in their blimp to go through the process of getting that 510K. As it turns out, for us, that was a fool's errand. But in February, we submitted a submission to them. Ironically, the day after the Table of Pharmacogenetic Associations was published, and we were pretty irritated that there was no hint of this at the time we were talking to the FDA. But the results of that submission, what we heard back was, the first special control was that we needed to prove out the analytical validity of the tests that we got. We needed to prove specificity, sensitivity, limits of detection. And in our original submission, essentially we had said that these labs will be CLIA and they will be CAP for proficiency testing. And we heard that's not good enough. The other thing we heard in the first submission was not only did we need to document the drug-gene interactions, but the individual variants that were used, we needed to go to the sources. Essentially what they told us was that CPIC, PharmGKB, Dutch Pharmacogenetic Working Group, they were not what they considered regulatory grade in their recommendations. So we had to go to the primary literature and work that out. So you'll notice there's a bit of gap in time here. And an interesting thing happened in 2020. Essentially, our business was in free fall. Everybody who had a genetic analyzer had switched over to COVID testing. Nobody was going to the doctor to get tests. Essentially, we had considerable attrition in the company. Essentially, we went from 13 people to 3. But we were able, with 3 people, to get out in, I believe it was 2022, we were able to get out an update that was largely based on, that had been done before the real crisis set in. We got feedback from that, tried to incorporate it with a new team, submitted it in October 15th of 2022. In August, we got back a letter saying that we were not substantially equivalent to our predicate. And honestly, we never wanted to be substantially equivalent to 23andMe. But the implications of that were we needed to come off the market. So December 31st, New Year's Eve at 7 p.m., our product came off the market. So given the time frame that we had to put in that first submission, this is the best we could do in terms of what we could support, develop evidence for. So it's 7 genes, 27 drugs. And my big worry during this is not commercially attractive, right? It may be, even if we'd gotten approval, if we were forced to put this panel out when everybody else was doing something commercially viable, we were very worried about that. So these give you a sense of what the binders are. This is what we sent in. The actual evidence was in 3 very heavy banker's boxes. So here's what the evidence that we needed to support was. First of all, was a gene important for the drug, for the whole analysis? Secondly, was the variant important? Could we support the activity, the change that variant made in the activity? After going back and forth a lot, we finally decided that there was really no other source other than the consensus nomenclature for haplotypes and diplotypes, and likewise for the phenotype. But in the end, the relationship of the phenotype to the drug, that is another area where we needed to do evidence review. So first, to establish proficiency, we need to say, what are the degrees? Originally, there was some talk about we needed an MD involved. We finally came back to the idea we could have a master's level person that was accumulating the evidence, and then a PharmD or some other person with training could sign off. First step was the PASS scale. This was originally suggested by David Thacker and tweaked as we went on. But essentially it was to say, how do we grade this information in order to say what's includable? And it was kind of interesting, as all these gradings were developed, everybody had an intuitive idea of what they thought it should be. And then when the scale may not agree with that. So you'd have to go back and forth and say, well, did we miss an element of it? Was it not, sufficiently refined? For the variants, this was a pretty large effort to collect information about the variants. So all the studies that were relevant were processed by our team in the Seattle area. We also got a company called GeneBox in India to do a separate analysis of the papers. And in the end, there was an adjudication process to determine when there was a disagreement, how we worked it out. Interesting. So haplotyping is, if all science is either physics or stamp collecting, haplotyping is somewhere between. If you have a full genome of clinical depth everywhere and it's fully phased, then it's a physics problem. In the real world, it's stamp collecting. So we had, our original haplotyper was algorithmic, and through lots of iterations, we figured out how to make it work right, with table-driven. The second generation was completely table-driven. Essentially, we would say, here's the panel for the lab. Let's figure out everything that they should call. Let's figure out what all the ambiguities are and pre-configure for those. That was a big job, and every time a new panel came in, it was a pain in the neck. This, actually, the upper part is from some work I'm doing right now that's kind of a hybrid between the two. You can see we use consensus nomenclature for phenotype. We're using data directly from FarmVar now for the haplotypes. Oh, this is another, a mistake we made here is that what we tried to get approved was the SOP, the process for coming up with these haplotypes. What we would do in the future is say, the heck with what the process is, well, we can't go that far, but essentially, let's do an analysis after the fact. So create synthetic samples that show this is what we think the call should be for every position, and then compare that to what the process calls and say what's the difference, and there will be differences. And we should be able to explain what each of those are. So this, based on the data you have, this could be a 1A or 1K. And this is why we called it this way, because of the prevalence of it. And what we've always done is said, if there's an ambiguity, and it's ambiguous among diplotypes of the same phenotype, then we'll just take the most likely. If there's an ambiguity that you can't resolve, let's say there's a copy number and you don't know whether it's in a null allele or a fully functional allele, then we have to say, okay, this could be this or that, and everything downstream would reflect that. So when you send out a recommendation, you would say, this was an ambiguous result, and here's what the possibilities could be. So phenotype specific, this was essentially the information about how to decide what was relevant. Big topic is what's relevant in terms of to be included in drug gene. So why were we not substantially equivalent? First of all, we could not guarantee the results of every lab. We you know, at our peak had over 100 labs. There's no way we could do that. I thought about, we had a contract with a pharmacy at one point, and they were maniacal about their supply chain. So Brahman Rami defined an auditing process where she would go to our labs. We thought about extending that, and that's not really what we do. In you know, complete retrospect, well, my experiences at that time with the Department of Health, the New York State Department of Health, were not very good, but using someone like that to do that, partnering with someone like that might have gotten us past that. There were, you know, to be fair to the FDA, there were, because we went through different teams, there were inconsistencies in the results we provided with previous results, and even within the information that we provide. Really ironically, the primary reason that people used us was because of our reports, because they were lucid. But the comprehension study was not sufficient from the FDA's perspective. It's interesting, Ashley Sherman is here, she will have more perspective on this. She went back and looked at the comprehension study. It turned out that if the report were given to a nurse and said, what would you do with this result? She said, well, I would go talk to a pharmacist. And that was considered a failure of comprehension. I actually consider that a success. So where do you go from here? The obvious question is, do I own an Argyle sweater vest? And I don't. But last week there was a Stripe meeting where the FDA communicated to us their plans for pharmacogenetics. And the good news is it's very consistent with what we were asked to do. And the bad news is it's very consistent with what we were asked to do. And at one point they said, well, they will accept evidence, they will accept our information with sufficient evidence. And Josiah, we could hear you screaming at your at your laptop. What is sufficient evidence? But I've come to the conclusion that we need a way around that. So if we look back at 2019, if you look at the statements that were made by the FDA, the relationship between DNA variations and antidepressant medications has not been established. Well, I have a quote, I couldn't find it for this presentation, but I have a quote from Francis Collins that says exactly the opposite. Likewise, we're unaware of data establishing the relationship between genotypes for sertraline and escitalopram. My understanding is the FDA still stands by that. Interestingly, in that June meeting, we submitted the evidence to them, and we had asked for CEDAR to be in the meeting, and they weren't there. But Tim Stenzel said to us, well, you have to understand that, that there is some evidence that's produced at the time the drug is approved that is not public. So we kind of think the deck is stacked against us in terms of presenting evidence. So, in fact, in the response to us, and again, to be fair, they were pointing out an inconsistency in before this. They said essentially use the table of pharmacogenetic associations. So here's my suggestion on how we go forward. We break down the problem, and this comes from internet, essentially create a separation of concerns among the different aspects of what we do. The first is create an IVD at the lab level for analytical validity. Lobby for the people who are providing tests now to create IVDs out of them, or get a third-party reviewer. Secondly, create a rigid panel definition, and I am working on the ability to get that haplotyping done and do it in a way that could be approved. And then third, the carve out for clinical decision support, take advantage of that. What that looks like architecturally is the data comes from the lab, it is processed, you come up with something like a report that has the table of pharmacogenetic associations that are associated with that test result, but you also create a standardized way of pushing this into the EMR, so then you can do clinical decision support. And Dutch Pharmacogenetic Working Group should be here as well, but essentially it would provide the physician with everything, every bit of evidence that exists. So this is the approach that I would love to move forward with. If you have any capability to partner with us, or if you have any suggestions for me, I am very much open to it. Thanks very much.